would like to invite Miss Mogana, Dr. Mogana, apologies. She's actually our lecturer in Monash in the Department of Economics and Business Statistics. And she has actually been in the data science field for like more than 5 years. And she's also working as a data scientist. And today she'll be sharing with us about the machine learning algorithms for a democratic data ecosystem. So let's give a round of applause for her to come in.
Good afternoon, everyone. I know that it's 3:40 almost now, and it's sleeping time. Okay, right. So I will try to keep this session more engaging, so I don't have to introduce myself. So as our friend has introduced me, so just a very quick briefing on my journey related to data science, because we have been hearing these phrases like big data, data science, artificial intelligence, and all those stuffs, right? So where does this data science comes from? Before that, let me collect some data before I start my session. Okay, so how many of you are from computer science or IT background? Computer science. School of Business? Okay, law? Okay, other than this? School of Science. That's interesting. I was from School of Science as well. So I did my bachelor's degree in bioinformatics. So science person, a pure science person, turned into a data scientist. We're currently in a business school. Okay, so that's my journey. All right. So today I'll be covering machine learning algorithms for a democratic data ecosystem. And before that, I would like to share a very small story, because when it comes to data science, it's interesting to talk about data storytelling. How many of you have heard of this data storytelling? We know what is storytelling. Okay, we have participated in these storytelling competitions, right? Okay, so during our primary and secondary schools, what is data storytelling? Can you guess? Data storytelling? So it's more on, we start our story with the raw data that we collect, and then we have to explain each and every step that we perform using that raw data until we reach the stage of the final results, until we transform the final insights to the end users or the stakeholders. So being a data scientist or anyone in this business intelligence or this big data analytics field, the main challenge is transforming the final insights to the end user. So coming back to my story, right? Because I forgot my story just now. All right. So during lunchtime, I was discussing with the keynote speaker. And then I asked a question where, what is the adoption rate of data science in our country's database or something related to election data and all? He asked me a question which frightened me, all right? So he asked, what is data science? So, and how could we apply that in, big data and all? And then I defined data science, okay? Then he knew that they have been doing that, but then they didn't know that that is the definition of data science. So it's not something which is very far away from us. We have been doing this data science since the beginning, where we have the data, we perform our analysis, and we transform the insights to the end users. Just that the techniques are different. So there is another common question from those who are not from technical background. Why do we need to transform from this conventional statistics and analysis into AI or big data or data science? The main reason is the volume of data, big data, all right? And how do we define big data? How do we define big data? If you are analyzing a data set with 6 observations, so interestingly, just in our assignment 4, okay, during week 12, a student came to us, me and another tutor, having just 6 observations in the data with 6 countries, because the assignment is to develop a machine learning model. All right. So came to us asking that, is this 6 observation enough to develop a machine learning model to predict what's going to happen in the future, to provide a recommendation, right? Do you think that 6 observation is enough to predict what's going to happen in the future? Is that 6 observation enough? No, not at all. So then, I found that the theory of this big data is not there, right, among the students. So that's why they don't know what is the difference between big data and a normal data. So by using Microsoft Excel or some conventional statistical tools in our daily life, we have been analyzing data, but we do have limitation for the total number of rows and total number of columns that we can have in that software tools. But when we transform into this AI, cloud-based databases, and then this machine learning, Power BI, Tableau, and etc., we don't have a limitation when it comes to handling a data. That's what called as big data analytics. So yeah. So if you're wondering, am I performing big data analytics with 6 observations? I would say no. All right. So yeah. So you need to understand that first before transforming from conventional statistics into data science or machine learning. And when it comes to the data landscape today, right, the big data sources dominate, of course, we know, and leading to centralized data storage that presents challenges and biases. Okay, and the need for better representation can help address these issues. So why the centralization of data is important is because of the lack of integration between different departments. So let me share a story of mine based on my experience. My PhD research was on healthcare analytics. Okay, I started my data science journey by analyzing healthcare data. My research was focused on breast cancer survival prediction. Then I was working closely with the hospital in Klang Valley. Okay, the data set is from that hospital, and the basement, all right, for all this AI, machine learning, and etc. is the integration of data from different departments. So if you would like to collect the data of patient A from different departments, it took like 8 months for me, because the integration was not strong enough. So can you imagine the data of this patient in surgery department, in pharmacy department, and then in pathology department, okay, are not integrated, where they have to extract manually from each data storage. Only then we can combine and perform a predictive analytics. So I think that by the time we collect the data and analyze, the patient will be no more. Right? So it is saddening, but this is the challenge when it comes to centralization of data, the data, right? The importance of integration in data sources where we are lacking in. So we means most of the industries actually. So it's not only about healthcare industry. Almost all the industries are lacking the process of integrating data from different resources for timely decision making and prediction. Yeah, so that is the challenge when it comes to democratic data ecosystem as well. So this one, I have cited the source as well. Okay, so it's a recent statistics on the global data generated annually, and they have predicted for 2024 and 2025 by using machine learning algorithms as well, by using supervised learning algorithm. So of course, we know that the data which is being generated, it is increasing yearly, and the data is not only about the research data that we are talking about, or data from government or private institutes or what. So we are surrounded by data. So I'm talking now, you are listening, right? That is also data in audio format, unstructured data. So now, like just now I asked you a question, right? How many of you are from IT department? So that is also a way of data collection, what? So this is how data is being generated every second, okay? Then, yes. And you can also see, I took this diagram from the same website as well, okay? So you can see the category and the proportion. So for the category, it's on the types of data: video, social, gaming, web browsing, until audio. And on the right, you can see the type of media. All right, type of media, amount per minute and amount per day. Interestingly, email sent is in the first rank. Why is it so? Can you imagine? Because when we send an email, we can copy so that it's black and white. So when we send an email to our boss, we can copy to someone, right? Okay, so I've informed this to my boss. So he can't say that you didn't inform me, correct? Okay, so it's also about the security of the data, privacy and security issues. So that's why email is still leading the data protection and also security. Of course, social media, I would say personally, my opinion, it's not advisable to share important or personal information, confidential data through social media, because it's being saved. But emails are also being saved. Yeah? Okay, emails are also being saved. Right. Next, why we need a democratic data ecosystem, as I mentioned just now, the integrated or centralized data, is because of the biases in current machine learning algorithms. Yeah. When we talk about the biases in machine learning algorithm, for those who are new to machine learning, so let me explain quickly what is machine learning. Imagine that it's a robot, it's a machine, and human needs to communicate with the machine by providing data and instructions. That is how robots work, right? We will program the instructions, step-by-step instructions to the robot. Only then it can perform a task for us, right? Yeah. So the same thing, the same concept for machine learning. We provide the data and we provide the instruction. We will train the machine. Now, by using the model which has been fit into the machine or the program, it is going to predict what's going to happen in the future with a new set of data. So the new set of data will not have any decision, and the machine is going to make the decision for us automatically. So this is how machine learning algorithms work as well. And when we talk about machine learning algorithms, there are various types of machine learning algorithms, and each machine learning algorithm supports different types of data. That is where the integration between different data sources is important. So when you integrate data from different sources, like you can have structured data, you can have unstructured data, let's say image data, as our previous speaker mentioned, right, about the image analysis, remember? Yeah. Then we will have a free text data, also the sentiment analysis from Instagram post about the COVID. Yeah, all these are this machine learning analysis using different types of data. So we call these different types of data as multimodal data. You can go and Google multimodal data. To prevent the biases in machine learning algorithm, we need to produce multimodal data first before fitting in the data to the machine, the robot. So that when the robot is training the multimodal data, it gains more insights, correct? Logic? Yeah. Only then it can make the prediction more accurately. So we can increase the prediction accuracy for an efficient decision making. Yeah. So that's the bias on machine learning algorithms. Then foundations of a democratic data ecosystem. So you can see the inclusivity, equitability, and transparency are the core principles of a democratic data ecosystem. So I can talk about the transparency, okay, when it comes to data as well. Even our keynote speakers and also the other academic speakers have explained about the transparency in sharing data. So it's not easy to share data because of confidentiality issues. But then, without sharing the data with the right personnel who can solve the problem by using the data science techniques, eventually we are not going to get the right predictions. We are not going to change the method that we have been applying all this while. So this method is not giving an efficient decision. So you are struggling, which is your problem. Because data science is problem solving. I would define data science as problem solving. But then if you don't share your data, if there is no transparency, if the data doesn't go to the right hands, you're still going to face the same problem. How are you going to find a solution to the problem, right? So we need to find a way in order to solve our problem so that transparency is important, but it depends on the types of data as well. Because of course, you will agree with me, transparency could not be applied in every domain, right? Yeah, okay. Then, yes, so I explained about the training data just now. Let me give you some suggestions on the data diversity can be achieved by, okay, so the centralized data to produce a good quality training data, to train the machine, right, to make decisions. We can add more data from underrepresented classes, okay. Then, by gathering data from different sources. So usually we will just focus on gathering data from one source. Especially when we are conducting research, we'll just focus on our research. Okay, we won't like mingle with another research group to share data. Alright, so we must start to collaborate. Okay, we must start to collaborate. So this is where the interdisciplinary projects or problem-solving case comes in. So when we collaborate, we can share data even like internally with different research groups, and then we can produce a good quality training data. Then number 3 is a bit scary, but it is also one of the methods where you can improve your training data. By data augmentation or artificially manipulating data sets. So, you know, by using our generative AI tools like this ChatGPT and all, we can create our own data sets. Okay, so you just give the right instruction, the prompt, and then it is able to create a data set for us. So how can we produce an augmented or artificially generated data is where you have to provide your original data first, and then you have to ask a question, all right, to ChatGPT or BART or any other software tools to generate a data something similar to this. But don't stop there. Let me give you a tips. Okay, don't stop there. So you have to add on some criteria, spend some time. Okay, you're just communicating with the machine, right? So you can add on points like if it is a numerical variable, you can specify the values like minimum and maximum. Can we do that? And then if it is a categorical variable, you can specify like, okay, there are 2 categories like gender and female. So I want like 50% for female and then 50% for male, something like that. So I'm just giving an example. All right. So add on these criteria to increase the accuracy of the data, but not stopping there as well. Once you generate the data, you can again evaluate the quality of data. We do have many methods to evaluate the accuracy of data in statistics and also by using machine learning, right? So you can evaluate and make sure the data is good enough to proceed with your decision making. Yeah. So then we have hiring applicants for the AI development process, of course. So this is again collaborating with different expert pool, improving transparency and accountability, introducing regulations to build diversity and inclusivity. Yep. Okay. So this is what we can do to improve the training data. So I would like to share one success story by integrating data from different resources. by using an open source platform which is being used by most of the companies worldwide, which is this OpenStreetMap. Have you guys heard of this? Yeah. So it is a collaborative project to create a free editable map of the world. And then unlike the other data sets, the OSM is driven by a diverse community of mappers, coders, and enthusiasts. So anyone can actually fit in data there. So for our real-time example, I would say that Waze is something similar to this. We are using Waze. You can add on data, right? So you can inform if there is an accident, if there is a police there. You can also communicate with the other Wazes on the road. So this is also an example of data integration and centralization, where they don't only make predictions or decisions by using the existing data. At the same time, they collect the real-time data and they revert back to the users by using the real-time data, making predictions in real-time basis as well, right? Yeah. Okay. Yes. Tools for building a democratic data ecosystem. Open source tools and platforms play a crucial role, definitely. And we need to introduce resources for further learning and implementation to empower individuals to take action as well. All right. So my summary would be, give importance to transparency of data, sharing data between different departments to solve a problem efficiently, to make timely decision, and to come out with efficient decision making or a framework. Yeah. And then develop more open source resources instead of, so you need to follow these rules in order to get the data. So it will take like 8 months, 2 years to get the data in your hands. So I would suggest that the institutes or policy makers can come out with simple rules at least, so that they can just process in 2 to 3 weeks, not days, just weeks, okay? Then we'll get the data in our hands, so then we can start our analysis already. Okay? So these are the things that I wanted to cover today, my end goal. So overcoming obstacles, definitely the data privacy, quality, the security concerns, the same things. And the last part would be decision making. So in order to make a decision, we can make use of all these machine learning algorithms. But again, going back to our first square, data is the new oil, right? So you must make sure you know what your data is telling you before you start your analysis. So don't just directly jump, okay, I want to perform machine learning analysis using this data. Straight away put the data into your Tableau and then you can analyze, come out with your result, and you start in interpretation. Don't know what the result is going to tell you. And then how would you explain to your end user then? So spend some time, we have to spend, not some time, we have to spend a lot of time understanding our data. Then the analytics is the same on any kind of data actually. All right. So that's a quick sharing from me. And I hope I shared some information quickly with you guys related to machine learning and also this data privacy and issues. So thank you. And do you have any questions? Question? No questions? One there. Yes. I think you can ask from there. Good. I can hear you.
Yeah, thanks for the presentation. I think, so one question from me, I think it might be a very dreaded question, is earlier you mentioned obviously 6 observations is not big enough, right? But when it comes to machine learning, when it comes to big data, normally in econometric analysis and economic analysis, the dreaded question is how big is big enough, right? Yeah. But when it comes to machine learning, what is a rough rule? Is there even a rule of thumb, or is there like a certain number of observations you're looking for in a data set?
Right, that's a very good question, a question which I received from students as well. In machine learning, we have no threshold for the data set. How we evaluate whether a data set is good enough to proceed with analysis is by using the accuracy of the data. So let's say like if you're using 100 observations, then your accuracy is good enough, 80% and above. For me, my threshold is 80%. Based on literatures, it's 70%. Okay, based on literatures is 70%. If you reach an accuracy up to 70%, that number of observation is good enough to go. Yeah. Right. Any other questions? Yes. It's based on literatures. Actually, we don't have a fixed number. It's based on literatures mostly. They report that if they reach an accuracy of more than 70%, the data set is good enough to proceed with predictive analytics. Yeah. You want to continue?
Okay, so we actually practice as much as possible, right? So we will try to collect as much as possible. And a key about KR right, is actually an iterative process. You collect, you do your data exploration. From your exploration, you usually have a form of descriptive analysis and inferential analysis. Present what you find to the stakeholders. They will give the feedback if it's sufficient to move to the next level or not, or if more data is required. Then only you go back into the same loop. Right, so you will be stuck at the loop of data exploration, data cleaning / transformation until your stakeholder actually say it is okay, only you go on to the modeling aspect. So different fields have different requirements. For example, breast cancer, obtaining medical data is very difficult, so a few thousands is usually enough. When I profile people online, I have 23 million users. Right, because online it needs to be large. So it will actually vary based on the use case. But importantly, since you're building a narrative, finding for the stakeholder in the end, it's a continuous process discussion front and back. So there's no magic numbers, unfortunately. Yeah. So even the number 70% depends on the number of labels. Right, so if it's binary true or false, 70% is considered low. It should be around 80% and above. But if you're looking at emotions, right, you have 8 different emotions, even accuracy of 60% is already enough. So again, depends on the outcome, depends on the labels, use cases, blah, 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 a bunch of stuff. And even accuracy may not be a suitable measure, it can be recall as well. So for example, if I go find cancer, accuracy is quite important. Recall is more important because if you have cancer, I need to find it even if it's a false positive. No, yeah, if it's a false positive, it's totally fine, right? If I get a true negative, no one cares. So depending on, like, it's not a defined field, that's why multidisciplinary actually happen. Yeah.
Yes.
Okay.
All right. Thank you. Okay.
Question. No question?
Question?
No, Mike.
A lot of questions.
Hi. Sorry, this is going to be a bit of an amateurish question because I'm just wondering something like from the perspective of someone who doesn't have much experience with like machine learning or the collection of big data, right? Like at the current moment, personally speaking, I am familiar with the various applications of like collecting and analyzing big data in various different frameworks in society, right? It is used in a variety of different areas like the criminal justice system to straight up like making predictions in the future about possible trends. And other than like this being a tool for say businesses to use, for example, and the map example that you had mentioned earlier in your presentation, I was wondering if there is something about the nuance in machine learning algorithms and like what exactly are some larger impacts that they can also be applied to in the real world.
Okay. So you're asking about the larger impacts of machine learning algorithms apart from the predictions, right?
Yeah, like just like how is machine learning algorithm like applied in like various facets of society?
All right. Okay. So one thing, obviously, for machine learning algorithms, we know that we can perform predictions. What's going to happen in the future, right? Based on the existing data, the past event data. Apart from this, I would say that feature engineering is another important function of machine learning algorithms, whereby using this feature engineering, we can examine each contributing factors, okay, to the target variable. Okay, so let's say like if you're analyzing social media data, right? So let's say, for example, the Instagram data. So you have a target on analyzing the positive and also negative comments on a particular subject, all right? So the contributing factors can be from different fields, like it's based on like demographics, or it's based on their experience, it's based on their personal emotions, and etc. So by using the feature engineering, okay, feature engineering method in machine learning, we can analyze each and every contributing factor in detail for the target. Yeah, so this is another advantage of machine learning. And the growing algorithm, I would say, is deep learning, where we can analyze unstructured data. By using conventional statistics, we can only analyze structured data, whereas by using machine learning algorithms, we can analyze any kind of unstructured data. So you can fit in video, like for football, right? So we can fit in the deep learning algorithms to extract the objects and come out with the structured data about the event of the game. So the advancement would be on unstructured data and the feature engineering. Yeah. Right. Okay. Did I answer your question? You asked about other applications of machine learning, right? Yeah, right. Yes. All right. Thank you.
Thank you, Mogana.